this lesson, you will learn to understand the properties of the normal distribution and know how to use properties of the normal distribution to calculate probabilities and percentiles. Before starting this lesson, you should be familiar with the concepts of mean and standard deviation. The normal distribution is a special distribution whose graph is bell-shaped, with the mean in the center and a standard deviation that controls the spread of the bell shape. Examples of data that could have a normal distribution include heights of 20-year-old females, SAT scores, IQ scores, or the size of trout living in the eastern Sierras. Normal distribution is symmetric, so half of each percentage is above the mean and half is less than the mean. If your dataset is approximately normal, then 68% of the dataset is within one standard deviation of the mean. That means 34% on each side. So if this is the mean, you have 34% on each side. 95% of the dataset is within two standard deviations, within this space. That means an additional 13.5% on each side. Then 99.7% of the dataset is within three standard deviations, so within this space here. That would be an additional 2.5% on each side. Let's look at the example of IQ scores, where the mean is 100 and the standard deviation is 15. Your graph data would look like this normal curve, where the final graph can be sketched like this. First, sketch your graph. Then label the x-axis by labeling the mean 100 at the center of the curve. Then you'll mark out three standard deviations at 85 and 115, at 70 and 130, then at 55 and 145. If my IQ is 115, what's the probability someone will score less than me? Or, in math speak, what's the probability x is less than 115, where x equals a person's IQ score? If my IQ is 115, what is my percentile? We will solve this using the empirical method. And to find that, you start with finding where your IQ is on the normal curve. 115 is right here. Then you add up all the percentages of IQs below yours. In this case, we will begin by adding 2.5% plus 13.5% plus 34% plus another 34%. Adding all of those up together gives us 84%. This means that 84% of the population has an IQ less than 115. And this also means that your IQ is in the 84th percentile. Now it's your turn. Assume IQ scores are normally distributed, where the mean is 100 and the standard deviation is 15. If your IQ is 130, what is the probability someone will score less than you? Pause the video to work out the problem. Click play to continue. Let's look at how we could solve this problem. We'll solve this using the empirical method and labeling the normal curve with the given information. The mean is 100, so we'll go ahead and write 100 right in the center of our normal curve. The standard deviation is 15, so we'll label three standard deviations in each direction. So that's 85, 70, and 55 to the left, and 115, 130, and 145 to the right. The area under the normal curve shows the probabilities, depending on how many standard deviations you are from the mean. We'll fill in the percentages for each standard deviation. So if we look in here, each standard deviation represents this area here. So 3 standard deviations less is going to be 2.5%. 2 standard deviations less is 13.5% for this amount right here. 1 standard deviation less is 34%. So this area right here represents 34%. 1 standard deviation above is another 34%. 2 standard deviations above is another 13.5%. So this amount right here is another 13.5%. And then 3 standard deviations above is 2.5%, right here. Okay. To find your percentile, you start with finding where your IQ score is along the bottom of the normal distribution graph. 130 is 2 standard deviations away, 2 standard deviations above the mean. That means that the probability of scoring less than 130 can be found by adding up all the areas here below 130. Okay, so that means we add up the percentages, 2.5 plus 13.5 plus 34, and plus 13.5 again. So adding 2.5 plus 13.5 plus 34 plus 34 plus 13.5 adds up to 97.5%. This means there is a 97.5% chance that someone has an IQ less than 130. This also means that your IQ is in the 97th percentile. Let's look at another example of what we can learn using a normal curve. Assume class test scores are normally distributed with a mean of 75 points and a standard deviation of 3 points. What is the probability you scored 80 points or higher? Let's start by sketching our normal curve and labeling the standard deviations. So first, go ahead and draw your normal curve. For this example, the mean is 75, so we'll put a 75 right in the middle. Since the standard deviation is 3 points, we're going to label 3 of those above and 3 below. So our standard deviations would be at 78 and 72 for 1 standard deviation away, at 81 and at 69 for 2 standard deviations, and then 84 and at 66 for 3 standard deviations away. Now, we want to find what the probability would be of scoring an 80 or higher. This means we would look at the area above 80 on the normal curve. Look at our normal curve, and you can see that 80 is not right on one of our standard deviations. This means that we couldn't find an exact probability using the empirical method as we did before. For this example, we are going to use something called a z-score and a standard normal table to find the probability. The z-score represents the number of standard deviations our value is away from the mean. The table will help us to associate probabilities to that corresponding z-score. In the equation for the z-score, we let x equal the amount that we want to find the probability of. So in this case, x is equal to 80. The Greek letter mu, which looks like this, mu, represents the mean, which in this example is 75. And the Greek letter sigma, which looks something like this, is the standard deviation. And for our example, the standard deviation is 3. So the z-score is found using the equation z is equal to x minus mu divided by sigma. So to find the z-score, you take the amount that you want to find the probability of, you subtract the mean, and then you divide that by the standard deviation. So for this example, that would give us 80 minus 75 divided by 3. This equals to 1.67. So once you find that z-score, you can use a standard normal table to find the probability. First, you look for the first 2 digits of your z-score, in this example 1.6, along the left column. Then you look for the 3rd digit, which would be 7, along the top row. Then the number where those meet is your probability. In this case, they meet at 0.9525. So the probability would be 0.9525. Remember though, that this amount represents the area under the curve to the left of our score. Since we're interested in finding the probability of scoring 80 or higher, we actually want the amount that's above 80. The entire amount under the normal curve is equal to 1 whole. So to find the amount that's above 80, we subtract the amount below 80 from 1. This means we subtract 1 minus 0.9525, which is equal to 0.0475. This means the probability of scoring higher than 80 points is 0.0475, so you will score in the top 4.75%. Now it's your turn. Assume the class test scores are normally distributed with a mean of 80% and a standard deviation of 4%. 1. Sketch the graph. 2. Label the x-axis by marking out 3 standard deviations in both directions. And then 3. What is the probability you scored an 85% or higher? Pause the video to work out the problem. Click play to continue. Let's look at how we would solve this problem. First, we'll label the normal curve with the mean and the standard deviation amounts. Since the mean is 80, we'll put in 80 right at the center of our normal curve. And then we'll label the standard deviations. So we have 84, 88, and 92 in one direction, then 76, 72, and 88 in the other direction. Now, we want to find the probability of scoring an 85% or higher, so we want the area under the curve above the score of 85. So 85 would be about here, and we're looking for the area under the curve above that amount. To do this, we need to find the z-score. So we let x equal the amount that we want to find the probability of, which is 85, and the Greek letter mu, the mean, which is 80. And then the Greek letter sigma is the standard deviation, which is 4. So the z-score is found using the equation z is equal to x minus mu divided by sigma. So we have 85 minus 80 divided by the standard deviation of 4. So 85 minus 80 divided by 4, that's going to be equal to 1.25. Now that we have our z-score, we can look at a standard normal table. We'll find 1.2 along the left, and then a 5 along the top. Finding the point where these intersect, we get 0.8944. Remember though, this is the probability of scoring less than 85%. This is the area to the left of the score on the normal graph. So we want to subtract that number from 1 to get the final probability. So we have 1 minus 0.8944, and that equals 0.1056. The probability of scoring greater than 85 is 0.1056, or you will score in the top 10.56%. In your notes, please be sure to write down each of the steps involved in finding probabilities and percentiles, both by the empirical rule method and by using z-scores and a standard normal table. For the empirical rule method, sketch a picture and label the mean and the standard deviation. Shade the region that represents your situation. Then label the regions using the approximations of 68, 95, 98, and determine the probability of your region by adding up the percentages. Now write down each of the steps involved in finding probabilities and percentiles using a standard normal table. First, sketch a picture and label the mean and the standard deviations. Shade the region that represents your situation. Then calculate the z-score. Use a table, spreadsheet, program, or calculator to determine the probability of your values. Then answer your question. In this lesson, we have discussed understanding the properties of the normal distribution and how to use properties of normal distribution to calculate probabilities and percentiles. See you in the next lesson.